whatever area I want to crop from this image, and then double click over this area, it will be cropped. So the particular area that I had selected, that only will be available now. Okay, so this was the tool of cropping, and we can measure the distance of 2 points. You can go to the image. If I want to measure the distance from one eye to other eye, then I can see that 50 pixels are there. If I want to measure the this size of the mouth, then I can say that some pixels. Then number of this is the distance. Okay, so this way we can you can measure the distance. Also, there is you can overview. You can see the pixel region. In a certain region, if you want to see the pixels, suppose here I want to see the pixels, I can just click over there, and 1 second, there is some. So I have to just extend some. This is visible. Where it is visible. So just let us tool go to the pixel region. See now. Okay. Now this particular region is this. It will come in a separate window, and as you minimize this separate window, will show you the pixels, pixel info. So you can view even pixel values when you go to the smaller region. Then you can see the pixel values, the matrix of pixels, which matrix I have selected here, that matrix is available. Okay, also you can import from workspace. You can export after analyzing the image, after doing some changes to the image, you can export it to the workspace. So if I want to export it into a new variable, okay, then in the variable C, my cropped image is there in the workspace.
So there is a question.
You can see the image information that which is available in the IMF info. So if you want to see the information of image, which kind of image this is, what is the intensity value, which kind of event 8, unsigned integer 8 type of values are here. These are the number of rows, these are the number of columns, like that. Okay, so this way you can see the image info. Also there is tool for adjust contrast. You can change the contrast of the image. Here this is the tool. You can see that the changes in the image. When I am moving from left to right, the contrast is changing. So here you can vary you can move this window, and you can see the change in the contrast. So you can change this. This is contrast change is coming because we are adjusting the histogram values. We are removing some of the higher level pixels. If you are removing higher level pixels, then this this kind of contrast will change. And if you are selecting these pixels, then this kind of contrast will come. I think okay. So this way we can change the contrast of the image. You can adjust according to the requirement. There are commands for automatically contrast leveling also. That is also there. Okay, then let us see that there is one more. Choose color map. So color map here there will not. Yes, you can see this. These are the different color maps that are predefined in the MATLAB. So you can apply color maps to the image. There was one question in the last class that can you convert a black and white image into color image? So this type of colors can be applied, but which fits to the image, that also you have to see. Actually, this image was black and white when I brought to this IM tool, but which color combination you want to apply, that you have to select it properly. So which will fit to the image. Okay. Just this was image processing toolbox. So now I will come to the point that how can we separate the A, B, C, or the grid planes, the planes of an image. What is the process of separating planes? So what concept I wanted to discuss? The concept is that the color image is actually made from RGB 3 planes. Yes, yeah, I already told that in the color image is the 3-folded one MATLAB matrix, and then other MATLAB matrix below this, and then other MATLAB matrix below this, like that. So it is made from 3-folded matrix, 1-fold to 2-fold, like 3-fold, 1, 2, 3. So 3-folded book covers, book pages are there. Okay, so when you have one RGB image, if I separate one fold, second fold, and third fold, then if I separate the one matrix R into R variable, R equal to whatever image, then first matrix will be stored into that, and G matrix is second matrix, and B is the third matrix from this image. Then how, what will be the color? Which color will look in the R? Which color will see in the R image? And which color will come in the G? Which color will come in the B? What will be the color of R? Can anyone answer?
Please write in chat box the value.
No. Answer. What I want, that this will be actually a gray scale. Let us see. Will it be red color? Will it be green color? Or it will be blue color? Let us see how to check. See.
So there is one answer by Anil Kumhar, Ankul Kumhar. It is 100. 100, I think.
Okay. I will do. I will read image. I will read one image. The discussion is little different. See this. I have read one image into MATLAB. You can see the size. Size is 253. I will show you size here. If you can write size command. See the size. Size of page 284 rows and 353 column, and it's 3-dimensional. So if I want to separate its first dimension into R, then R will be equal to A, all rows, all columns, and first matrix, means first part of the matrix is saved into R. And G, gray part, the gray plane, there are 3 planes. First plane is red plane, so I have separated first plane by this command. So for the second plane, command will be ::2. And for the third plane, command will be A: ::3. In this way, 3 planes are separated. Red, green, blue, but they will not represent the exactly the color map till the time you will make the other 2 0. For example, if I want to see the red part, for red color, for red color, this will be 255, and R should be 255, and G should be 0, and B should be 0. But if I take only 255, it will not show red. So I have to create these two zeros plane also. So I am taking creating zero plane as z equal to zeros of what size? We have image of 284 rows and 353 columns. This is one plane of zeros, and actually red part of image or red plane will be equal to, I have to combine this R. Okay, so all rows, all columns, and the first will be equal to R, and in the same red plane, the second edge will be equal to, second matrix will be equal to Z, because second will be 0. Oh, sorry, and the third should be also 0. Now you see this red plane. See, this is the red component. This is the red component of the image. You can see that this is the red part of the image. And similar to this, if I want to see the green part of the image, green component of the image, then I have to again do green plane or G plane. Same thing I have to do, G plane colon 1 equal to Z, and G plane colon 2 equal to G, because it will come in the second only, and G plane colon 3 equal to again Z. So what combination is required for the green? Green should be, first should be 0, second is 255, and third is, so second I will take G plane and third is Z. Then only I can plot this. This is I can show you the green plane of the image, the green part of the image, G underscore plane. Yes, it is shown, but it is in the background. I have made some mistake. I think G was the second. So okay, it's okay. It's that is what it's there. It's a green. Means in the image, this is the image. You can see outside the MATLAB. This is actually the image. In this image, the green component is not there. Means nothing is coming in the green part. Let us see the blue part also. So in the blue part, B plane, we have to take the first edge 0, in the B plane second at 0, and the B plane, oh sorry, B plane, this should not be like this, this should be like this. I have to take B plane 1 equal to 0, and then B plane second part is also 0, and B plane third part is B. Then let us see B plane, how does blue plane looks like. Recommend you. Why this is not nothing is coming in this B. Okay, so only red component is predominant in this. Remaining components are not predominant.
Sir?
Yes.
Suresh sir is asking for some repetition of this. Suresh
Yes,
sir, can you explain that which part you should want to repeat?
Yes, sir. Initially, how he is defining that RGB? I mean, 1, 2, 3. Is that and RG like that? How he is defining that? 238 to 245, the values.
Okay, okay. Just I will repeat the concept what we are discussing actually. What is there and how can we do. So I will come back to the point and then again tell you what we are doing. So I have one image in my folder. See, this image is there. Okay, and what I am trying that when I read this image into the MATLAB, when I read this image into my workspace, then you see that the size of this image, this variable is not just a row number and column number. There is a certain third number also. This is row number, that there are 284 rows and 353 columns, and this is repeated 3 times. That means a matrix of 284 rows and 353 columns is repeated 3 times. So overlapped 3 times. Same size, overlapped 3 times. So what I am trying to separate it. Okay. So how can we separate it? Can you tell me, sir? How can I separate? I want to save one matrix from this into B. What should I write?
One color, yeah. Any one color you want to say? Yes. Okay.
Yes, yes. So what should I write? B equal to A. All rows. I should copy all rows. For all rows, this colon is the operator. If you want to take all rows, then colon is the operator, and for all columns, this colon is the operator, and first plane of that. Okay. So what is the meaning? Now how does it looks? Let us see. I have just separated. You can see the size of B. Size of B is 284 rows and 353 columns. So first part is this. So this will represent R, red component. But when you see this, so when you see this, then this is the figure window. So this is actually not in red color. Okay. So what happened? Why it is not red? This is red component. Why it is not in color? What is the reason this is not in color?
Because we separated only one color.
Only one color. That's
one
why
column of matrix.
This yes, this will not show color. If I want to see the color, I have to add other part as zeros. That is what I was doing. I was adding the other parts into this separated red component as zeros, so that we can see the red color. That's what I was doing. Currently, what I wanted to make the point I want to make that the color image is made from the 3 grayscale images, or if we have 3 grayscale components of an image, we can make colors. That's what point can be done. And similar to this, the concept can be extended to the binary images. In the grayscale image, this is a grayscale image, for example, or we can convert it into the grayscale image. So in the grayscale image, we have 0 to 255 values, in fact. Okay, so 0 to 255 values are there. These are actually unsigned integer, 8-bit. Okay, so these can be represented in the binary 8 bits. 8 bits, and this last can be also a binary. we can represent all values in the binary range. So if I separate all the bit planes, means all binary values from this, then I can get 8 binary images. Is this true? Am I right? Do you agree with me for this? What I am saying, that if I convert,
Yes, sir. Yes, sir. We are having 8 planes.
yes, so 8 planes can be separated. So that how can we separate? How we need to convert this into binary, every pixel value into binary, then only we can get it. So to do this, what will be the process? For example, we have this number. For example, we have some number 20 pixel value. What we generally do to convert it into the binary? We divide it by 2 and save the remainder. So 10 will come, then remainder. Save the remainder again. Save the remainder. This is the process. So that process we have to perform over the image. Okay, so let me go. Let me just do this. So how can I do? I have already done this in my PPT. So that this is the concept is that for rotating and cropping is always still remaining. I will do bit planes. So we can get the 8 bit planes. This is the process. This is the algo. I have written here that we can do just by this mod command. Mod gives the remainder. So first of all, I'm here converting it into double. Please mute. Mic is on. So first of all, we have to convert it into double. Then why we are converting it into double? Because this mod function will work only on, which is a MATLAB function, so it will work only in the double. So how to convert into double? Just you have to write double and then the variable in which you have stored the cameraman image or whatever image you have. Okay, so then it is converted to double. Then I am doing what? I am just taking the remainder. So this will give you the we start writing from the last remainder, that is called MSB. When we divide a number 20 and by 2, then it comes 10. Then this is MSB or LSB. This is actually LSB.
LSB.
Yes, and then again when we divide it by 2, then we are moving towards. Sorry, this is 0 actually. So we are moving towards MSB. So last will be MSB here, isn't it? This is the process. So this is the LSB plane. Then when I am doing again the divided one, what is this floor command will do? Why I am doing this floor command? Why? Because sometime this divided by 2 will give the fractional value. So we need to convert it into the integer value. For example, suppose I am dividing 20 for 19. For example, we have 19. So when I divide by 2, it will give you 9.5. So then I have to convert it into 9 and then divide it. So that is what here I am doing. So it will convert it to the nearest lower value. Okay. So this then again taking mod. So this will give you the coming to this plane will be MSB plane. Okay, so this is when we see, if you separate these planes, then you will be able to see that most of the information is available in the MSB plane. A lot of mostly useful most significant bit we say. So mostly informative plane. So there will be most information in the MSB plane. When you see LSB plane, there will be less information in the LSB plane. So how can we do this? So the process is written here. You can try. Otherwise, I have also then this thing. I have written code in here. Same thing. Just I have written in the MATLAB code. So just I am reading this my image and then converting it into double. Then I am doing this. I am seeing the image at every so I am observing this image at every point. So I'll just take this program to the MATLAB. Okay, in a MATLAB. Okay, just take one new. Run this. So you can see the program that I'm just reading the image, converting it to grayscale because we are working on the grayscale image. That is already discussed that we are working on the grayscale image only. And then I am separating the first bit plane, mod CD comma 2, figure 1. Then I'm so this thing. Then again I'm doing this thing, this dividing this thing. This is one process. This is not that the only one process is there to do this work. There are many ways to convert the integer into binary. Then you can apply your own way and convert it into the binary. This is one way of doing the thing. You have similar to the chessboard. In the chessboard designing, I have seen a lot of people and to whom I have given this assignment. They were doing in different ways. So similar to that, for this also there are many ways, many other ways also. People know the way that explore the way how can we do. So that way this thing can be done. But ultimately image should be converted into binary. So my bit planes. I'm just naming this file and see. Yes. So now I have complete 8 images of from the grayscale image of mine. You can see this image had some information. Then the 7th number image have some different information. 6th number image have some different information. 5th one have some information, and now 4th one very distorted, very much distorted. Yes, then the 3rd figure, you cannot understand that whose image was there. And in the 2nd one, you cannot, this is completely jumbled noise kind of thing. And the LSB, when you see LSB, it looks like a QR code. Nobody can understand anything, isn't it? So this is used in the image cryptography. People utilize it in the image processing. Image processing person utilize it in cryptography. Yes, Padmalata madam, this is I call this method of cryptography is called LSB. LSB encryption. That you can hide your data, you can hide your information into LSB. Let me go to the MATLAB, and this LSB plane you can see this plane one number 1, figure number 1. This in this if you replace it with your information, what difference will it make? Already that it doesn't carry any information, and this information is not important for the image, because even if you make this completely zero for LSB plane, if you take, then also your image will be same. Or if you take any combination, then also your image will be same. Okay, so what means, what will be the, we can replace the binary, the LSB, with any other new information and hide it into the image, again combine with the image and send it. Steganography, one area of image encryption or image cryptography is called steganography. So this is very much used in the steganography application. Okay, so now we have separated it. Can we combine it back? Can I combine it? Similar to the, as we can convert any data to binary, we can convert binary to the same data also, isn't it?
Yes, sir.
So what should I do? What we generally do to get the data again?
Again adding.
Again adding with the weight of particular place. Okay. So again I have to add. I will take this again from here, that I have to add it again, and then I have to come back to this one. This is not this one. Okay, this one, and I have to add like this. I have to give the weightage. Then 2 to the power 0 to 2 to the power 7, C7, 2 to the power 7, C6, 2 to the power 6, 5, 4, 3, 2, 1, like that. Okay, so let me try whether this works. I will just put one more recovery. Okay, and this. So I have to save it. In some new variable, let it be I equal to, let us see, and then I can take new figure. You can give figure numbering also similar to this. So this is also helpful for you, that we can give figure number. So it will show in that number only, and it should be I. Okay. Let me see figure number 9. I am looking for figure 9. It's not coming. What happened? What is the problem? Oh, there is something missed. Anyone can anyone help? I will tell that we have missed something. What we have missed?
So there is the answer, decimal part by Dr. V. Sai Kumar.
Yes, we are here we are doing in the double data type. All the things that we are doing in the double data type, and we have not converted it back. So I will try this, that before showing. I will try this. I will try to convert it into the uint 8. Whether this works? No. I equal to. Just I'm trying. Let us see. Oh, this is working. This idea is working. What we had done in starting, we have to convert it back. That is the process. So if I have converted in the my integer into double, then I have to convert double to integer also before expecting the same image again. I have to convert it into integer also. That is what I missed. Yes, a fractional part only, because image is in the integer. Image was in integer. We have to see that part, that it will be shown in that part only. Now I will do the changes. What changes? I told that if I change the, I will change the C0. Instead of C0, I will write 0. It means nothing. I will not take C0. I will take 0. Then will I get the same image? Will I get the same image? Oh, same image is coming. That means LSB have no significance. Yeah, that is right. That least significant plane means least significant plane. Yes, yeah. So why? Because
Why for leaving MSB, sir?
I'm leaving. No. That's C0. That is C0. C0 is LSB.
No. I'm asking for do it
Okay,
for.
let us. Okay, if I do it for MSB, then what happens?
See to that.
C7.
C70.
Yes, if I make C70, then also we will get image, but it will not be of that quality.
Yes, sir.
Yeah, see that because we missed the main information, we cannot change MSB. If you want to do some encryption, or if you want to do some watermarking, if you want to do something, then you can make to the LSB or plane or next to the LSB plane. Only the first, second planes are allowed to, or third plane. Some people do. So we have 1, 2, 3 means LSB and next to LSB and next to next LSB. Then after that, you cannot change the information. Otherwise, we will miss the important information, and intruders will also know that something have been changed in the original image. So that is what this is a very we are planning one.
But actually, after adding the information, you got the image in terms of black and white. It is not coming. It doesn't mean that it is not coming. You have shown the black and white image. But after converting into unity integer only, we are getting the information. Means that is a grayscale image.
Yeah, image is grayscale only. Actually, I have converted into the grayscale.
Sir, figure 8 is a black and white image. Figure 9 is a grayscale image, right?
No. Yes. Yeah.
It doesn't mean that it is not. It is wrong. It is wrong. But so you can add one more image.
1 minute, madam. 1 minute. All the figures from C0 to C8 all binary images. These are not grayscale.
Yes.
Only
that is why
this image, figure 9 is grayscale.
Yeah. That is what I'm saying.
Only one image, figure 9 is grayscale. All images, they are not integer, they are binary.
Sir, before unit 8, before 22, you insert one more figure, sir. That information is nothing but binary image.
Yeah, that will be binary only.
Yes,
the binary data.
What I want to say. Okay. It doesn't mean you are not getting the answer, but you said no, we are not getting the answer. It is binary.
Answer is correct, but we are not showing it correctly.
Okay.
We are not presenting it correctly, so that people are not able to see.
Yes.
Answer is already correct. Answer was not wrong. Yes. Okay. So that's what we have done. That is what idea I wanted to communicate, that we can separate the planes of images, and we can similar to that. This is very useful for this image encryption or cryptography. We are trying to plan one session for cryptography also in image processing part. Let us see. There is. So one external guest speaker will come for the image encryption and image cryptography, how that can be done. So I have done one question for do it yourself. I will share this in the worksheet, so you can try these questions. what we are doing, we can do watermarking with the help of this. So we will try to mix up two images and other thing also. So this was for this. And then one thing we have missed here in this session, image cropping and image resizing, all things are required sometimes in the image processing. So you can simple commands are there from the image processing toolbox, like rotate. This command is used for rotating an image. I'll go and show you this command. For example, I have read in one image. And then I want to rotate this image A by 90 degree. Okay, then I will see it. See, this is rotated by 90 degree. Clockwise or anti-clockwise? This is rotated anti-clockwise by 90 degree. So if I want to rotate it clockwise, then what I have to do? I have to write minus 90. See, image is now rotated by clockwise by 90 degree. That's the way we can do rotation in image according to the requirement. We can have the command called imcrop. So be equal to imcrop image A. So when you write this command be equal to imcrop, this is for cropping an image. And just this image will show you when you write this command, image will come, then the one crosshair is coming. Just you have to press left click and select a region from the image, and then in between the selected region you have to double click. When you double click, it will save the region and it will show, you can see the part of the image. See, the cropped part is now saved into the variable B. Okay, so in this way we can do cropping of image. Also we can resize. Many times size problem is there in MATLAB. Size problem is there means when MATLAB matrices or variables are not of same size, you cannot perform many of the operations because it works on the matrices operations, and matrix of dissimilar size cannot be added, cannot be multiplied like that thing. So for that purpose, image resize is very useful. In imcrop, you can also give the locations instead of just manually going to select and going there, because many times we are writing programs, we are not going to select the area and execute this command. So that time you can specify like this in this syntax. One syntax is given here that you can give x minimum, this value x and y values, and then you can like this. So I will just give you one example of this also. Like in B, you can give the values like 20, 50, 100, 150. So and then you can see B. So means what I am saying, that if we know the places, the locations, from which location to which location we have to separate. You have done some image processing task, or some machine have decided that this is our region of interest. Then that region of interest is to be selected with the help of, can be selected with the help of this command. Okay. So this command can be used for that purpose. imcrop. So this is much more useful than the manually going and selecting the area whichever we want. So resizing also. So resizing can be done by a factor. Resizing can be done by actually value. So by factor, you have to write I am resize, and then where I, then factor. Factor, then there is resizing can be done in 3 ways. I will tell one by one. So if I have image A equal to this image and B equal to I am resize this image A by 0.5. See, the size of B is half. Here in the A there were 284 rows. In B only 142 rows are there. So I will show you both of the images by seeing. See, this is one image. I will take new figure. And then I am show B image. This image. This is smaller than the previous one. Where all two figures will come together or not. See the two. In all four, number of rows and number of columns both are reduced. Then if I increase the size again, if I want to see the back from B, then you can write 2. So this will be 2 times. But quality.
There is audio is not coming.
Yeah, but quality.
But this image and that image is not, the original image and this image is not same.
Yes, why?
The pixel values will be different.
Yes, these cannot be same. Why?
Yes.
Why? Because we lost the information. We lost some information
Yes.
in this conversion. When we have reduced it to half, then the half of the pixel information have been lost. So what MATLAB does in the background, I will just share that. That is there. What MATLAB is doing in the background, MATLAB is actually doing some repetition kind of thing. So you can see when we are scaling, then at that time when I was reducing the size, at that time this pixel x22, x24, x26, x42, x44, x46, these have been only selected and remaining pixels are rejected. So in this way the half of the size will come, that we alternately select the pixel, and when we again increase its size by 2, then they replicate the pixel, but originally these two pixels will not be x21, x22 are different, but when we are converting back, then these two are same. They are replicating the 1 pixel to the 4 pixels. These 3 pixels of same value will be created in the neighborhood. This is what is done in the background by MATLAB. So that is why this image, original image, and this image which is resized by 2, again that will not be same. Okay, so this is where that is where we are losing the resolution, like that is thing. So that is what was the actually basic thing in the image processing. Now next is operations over the images. We can perform certain operations in the images. So I will share that.
So there is a
Sir,
question by Srinivas Gagandeep.
Yes.
That can we compress image without degrading image quality?
See, image
Yes.
can be compressed, yes, without degrading the image quality.
We can do it.
Yes,
We
but
can reduce we can remove the redundant information so that
yes, we can compress, but
Yeah.
we cannot retrieve back.
Yes.
When we want to increase the size back, then there is a problem. If you are compressing, then there is no problem. So we can compress without reducing the quality, but we cannot come back to original. So there are ways. Yes, Srinivasa sir, there are many ways, and many compression algorithms are there, where lossless algorithms are there, lossy
Classic.
algorithms are there. So you can go through that. They will help you in that what are the ways we can do compression without.
DCT, DWT, these are all compression technique only.
Yes,
Discrete
yes,
cosine
ma'am.
transform, wavelet transform, all these
Yeah,
comes under compression technique. JPEG
DCT,
in JPEG,
DWT.
JPEG 2000 they are using this standard.
Yes, yes. Yeah, these all techniques are lossy techniques, and there are lossless coding techniques also. So that there are many techniques where we have to optimize again when which techniques is useful for our application, and how much we can go into that. So okay. So I think, or any other question, query?
No, sir, not now.
Okay, then I am going to discuss then operations over the images. Operations over the images are classified mainly as three types. First type of operations are called point operations. These works on the image pixel values without any change in the surroundings. Second kind of operations on the images are neighborhood operations, where the surrounding is means the change is dependent on the surroundings. For example, convolution and filtering kind of operations, there the neighborhood values are also important, because the window is moving from left to right or right to left, or up and down. So it depends on the neighborhood values. Therefore, these operations are dependent on the neighborhood values. So the third kind of operations in image processing are transforms, like Fourier transform, wavelet transform, STFT, like that. So then we transform the values into the other domain, in transform domain, and these are also very powerful and efficient for many applications and many analysis in image processing. Okay, so these are three major division of operations. Point operations are simple operations that can be done with the help of knowledge of matrices in MATLAB. If you know the matrices of MATLAB, then you can easily perform point operations just like that. I will so like addition, adding 128 to the image. So if you add any value to the image, what will happen? It will change all the pixel values throughout the matrix. When it is increasing to the value 255, when it is going above 255, then it will be masked or it will be saturated. It will not increase greater than 255 because data type is of uint8, unsigned integer 8, which will not allow values greater than 255. So the saturation will be there for many values, and the image will lose some information if you add these values, but brightness will increase. For example, I will show it by example. For example, we have image A, and if I add values in D, that A plus 128, it will add values 128 value 128 to all values of A. Then let us see A. Because a lot of figures are there.
D sir.
It will be confusing.
Sorry.
Sorry.
So D.
Oh yes. I have to write. I am so D. See this, because the values are saturated, so a brightness is increased, a white color is increased. Most of the values are going near to 255. So 255 is representing white color, and therefore it is becoming brighter. Image brightness is increased, So increasing brightness in an image is simple, adding some values. If you decrease, if I subtract, similar to addition, there is subtraction also. If I subtract values and save it into a new variable e, these are the simple operations. I am just telling that. Okay, see this brightness is now decreased. Image is becoming blackish. So black portion is now increasing in the image. This is the image subtracting some values from the image, subtracting a value from the image. Similar to this, we can do multiplication also. If I multiply a value to the 2 into the image, and see this image, again brightness is increased. Concept is similar, that now the values are increasing towards 255, and if I divide it by 2, and see, then the values are decreasing, the brightness is decreasing. So this is these are the point operations. By point operations, because operations are being performed on a single point, means point to point. Every point is subtracted, every point is added by 128. So that is why these are called point operations: addition, subtraction, division, multiplication, like that. There are commands also, although the process is very simple, but there are commands inside MATLAB image processing toolbox, like I am multiply, I am divide, I am add, I am subtract. Like you can directly also add and subtract, no problem. Now try this 1 minus m in complement of image. To find complement of image, we can do one thing, that not of a, then I am so G. There is a problem. Why there is a problem? Because the image was actually color image. This binary kind of operation should be performed over the grayscale image only. So I will convert it into the grayscale first. Then I will apply this. G equal to, not operation is this one, not of B. Now there is no error. See this complement. This is actually black. So all things have become 0. Okay, this one. But if you use this command, I am complement B, this will also do the same thing. But here the complement is different, because it is used the scale. So this is negative that we used to have in the previous days. Some day, 10, 5-10 years back, when there were so many digital cameras, then we had to see this negative of the image. So this is MATLAB command is actually, this command is some optimized. They have optimized these values, that which value need to convert to the what is scale. So this is actually not a complete binary. This is actually a grayscale kind of image, which are mixed values. So let us see that what is the data type and how does it looks. So see this G is not a binary data. This is actually unsigned integer data. Okay, so this unsigned integer data, and it is a see the values also. Let us see the values. See the values also are not 0 and 1. Values are some scale, grayscale values only. So this complement command is doing grayscale conversion, but this not of m, this will convert to 0, and this 1 minus m will convert to white. Here you will see white color. It will, I think it will come to be black color. Here you can see the actual complement of image. Okay. So complement is doing solarization, is also part of complement. Histogram we have already done using image command. Tool I have discussed also. This image contrast enhancement commands are there. Adjust command and histogram equalization command. So we can do this.
So there is a question.
Yes.
Can we get the reverse operation that is on the image values of matrices and all x, y, z values at any part or point of image by
one second. Yes. Can we get the reverse operation that is on the image values of matrices and all x, y, z values at any part of?
Hello.
Yes, sir. Can you explain that question?
My question is that suppose at any image is there of any land surface area. So at any point, I have to get the value of that, whether either x direction or a y direction, x plane or y plane or z plane, what actual digital values or the integral values are there. Can we get it from the, that is my reverse operation, because you had shown only to get the uh, uh, image formation, but I have to get the values in digital way, just in reverse back way, the actual digital or numeral value of any part of the point of a image or the cropped image.
Yes, sir. Yes. Yeah, we can get the actual values also.
Yeah.
In MATLAB, actual values are always there, sir. Just you have to go when whatever operation we are doing.
Yes.
I will show you. I will show you. For example,
Yes.
if I have one image,
Yeah.
suppose I have one image this A in the MATLAB, and I have done some cropping in B. Suppose B, I am doing some cropping of A. I will do the manual crop, for example, for your understanding, sir. Just I am doing the cropping. I have selected this region and cropped it into B. You can see that the command window is showing the values. It's showing these are the values. So these are the actual values. Still, if you want to, if you have done CLC and if you have removed these values, still you can access these values from here in the workspace. You can see the B is available, and double click on B. When you double click, it will show in a table. So this is actually these are the values. Each pixel value you can see, each pixel, not complete simple. Each pixel value you can see here. That what is the value? Not only you can see, you can also do changes if you want. Not here you can do. Just you can do changes by writing some function. Here also there is method, but because this is event 8 type, so you have to write in command window.
I see. Okay, sir. Thank you.
Okay, nice. So I will do this RGB to gray. Of A. This is saved in C. C is now grayscale image. I will show you histogram of C. This is the histogram of C. See, this is different from the previous one. This is different image, therefore histogram is also different. Okay. Now I will perform adjust kind of histogram. This is contrast enhancement of image B. These operations should be on not B, This should be C because B was not a grayscale. C is grayscale. So this operation I should have done on C only because it will not work on color images. Many operations or many of the commands do not work on the color images. They are designed for grayscale or binary images. Why? Because I already told that machine do not want to process lot of data. So if you take color images for processing every time, then it will take a lot of time to process. Therefore, in the grayscale also a lot of quality information is available. So machines generally use grayscale and binary for that purpose. So I have done IM adjust. Then I will see histogram again. See histogram is changed something. Let us take the figure and IM hist C. So this is one figure. Where is this figure? Another figure. Figure 2 and figure 2. Let us take histogram D. Okay, so figure 2 and figure 1. Do these two look same or these two are different? These look same in fact, or some difference is there. See, I have just plotted the original histogram of C. Then I applied this IM adjust command, saved into the D, and then I have plotted histogram of D. So there is some change. What happened? What change is there? In the figure 1, you can see the 0. See 0? There is differences. Find the difference. In the 0, near to 0, there is no pixel. No pixel have 0 values. But here, pixels are started from 0. At 255 also, so the top 1%. Top 1% is optimized. Here. Here also, it is optimized. So there is change. There is change. These let us see what change comes in the pictures. So I will show you both pictures also. I am show a new figure window. Picture C. And in the again picture B. Let us see in the images. Does image have also differences? But we can, I think images we cannot identify the differences. It's not so easy to identify. Or can you see the difference? I don't know whether this is transmitting the difference. I can see the difference.
Yes, sir. Yes, sir. In code, there is
Yes, sir, it's visible.
Contrast.
Contrast is increased.
Yes.
So that yes, so this is one method. IM adjust command that changes the top histogram, changes the top 1% and lower 1% of the histogram. So that they delete that portion, so the other portion comes to 0. So there is some changes in histogram, and that's why the contrast can be increased with this IM adjust command. These are the pre-processing commands of image processing. Some pre-processing need to be done before going to the object detection and other things. Okay, so this is one command. Another command is
histogram equalization also can be done for pre-processing.
Yes, histogram equalization. So that I am doing. So I'll save it into E. Histo EQ. This command is also there, and let us see the histogram first. That what change have been done in the histogram. So I will plot histogram of C. The figure 3 it is coming, and then histogram of which one? histogram of E. Yes. See, the histogram is changed a lot. Histogram equalization works on histogram. It equalizes the histogram. So you see now the histogram is completely different from this. This was original image histogram, and now this is histogram. So image is changed a lot. Let us see now image is better or not. So there is a lot of changes done by this particular command, and I will show you both of the images now. Image C and this is image C, original image, and image E. This is image now. So is this better or that better? You can see both of the images. There is change. Is there any change?
Yes, brightness.
Yeah, change is there. Contrast is increased. Contrast is increased, but this is not showing good quality contrast increment for this particular image. It may work for other images. Right?
Yes,
It's not
very
that,
dark, for very dark images, or it will work.
yes, it works for the other images. No, it is not that it will not work for all images. It will work for some of the images. Depends on the quality of background in the image. So, and quality of image, original brightness in the image. So these both of the commands, histogram equalization and histogram adjustment, this is IM adjust command, these both are used for contrast enhancement. Okay, so we can do contrast enhancement by, first thing is by increasing the, so this is actually changing the brightness only, and you can change the contrast by IM adjust and histogram equalization, these two commands. Okay, so these are again details of these two commands only. Thank you for your hearing in this session. If there is any query, I will like to take.
Image normalization, sir.
Image normalization is done by histogram equalization only.
One thing more, sir.
Yes.
While we are processing images, so two or three, four, or any parameters we can have. So maximum with the image, if I have been given to 3D, so at least three parameters we will be having to record. So in case of here we are getting the pixel value in matrices in X and Y, but
Yes.
how to we will be getting the Z value in 3D if the image is in 3D?
Yes. Yes. Sir, I think you are asking that how can we access the Z value
Yes,
of
sir.
image? Yes.
Yeah.
So let me tell you that image. I have one image here. C image. C is actually image. I will show you. C is actually image. So there are many windows open, so I will close all. Then I will show you. This is an image. C is actually image. Okay. So I am saying this is a 3D data. This have data in 3D. So how can I access this data? I can save it in Z data of this C just by providing some X value you have to give and Y values you have to give. X value and Y value we have to select. So the value, this C matrix, from this C matrix we can access any row number by giving X value row number, X in row number and Y in column number. So Z value will come. The Z value is 204. This way we can access the Z value. If you are thinking of plotting, that plot I have shown in my PPT. Are you asking for plot or only value?
Yes, for plot value.
For plotting also,
Mm-hmm.
that how can we plot these values?
Yes, sir.
Yes. Okay. So I'll just show you that also. Just you right click here, and you can use. There are commands. You can click on plot catalog. Instead of learning commands, you can see there are many plotting softwares are there. So 3D, if you want to see 3D, yeah, but I want actually that not image plot. These are image plots.
Yes, sir.
So image, if I select image, it will show image only. So image
Yeah, yeah.
command IMSC plot,
Yeah,
but
yes, sir.
we want the 3D surface.
Yes, yes.
So we can select from here that surface or mass. But that is also different. Okay, but I will select one. Let us select mass.
Yeah, of course, sir.
So these are the values. See, there is a 0 to 250. These are the values, and here also values are there. This is X and this is Y. These are Z. In 3D, we can see like that. And there are some other plots. So whichever plots which looks good, that can be used.
Good.
You can represent data and see the data, how data is changing inside the image.
Yeah.
So control plot is not useful here because we are not tracing the movement of data. We are just seeing the data. So mesh is okay. Mesh is okay. The plots have also different applications. And histogram plots only applicable for 2D images. They are not applicable here. I think bar plot, if we have 3D, and that is also, that will be useful for me.
Okay, sir. Okay, okay.
Okay, so because there are many values, so therefore they are not separated. Actually, that plot I had shown in the PPT last session presentation, I had taken very small 50 by 50 image. Therefore, this three-dimensional bar plot was visible, and but here there are so many pixels in the image that we in this resolution or in my screen resolution, every this point value cannot be seen.
Cannot be obtained.
Yes, but if
Okay.
the image size is very small, then you can click over the plot and you can see that value. Okay, sir.
Okay, sir. Thank you.
Sir, there is a question by Kapil Gupta that how
Yes.
can we export a high resolution image in MATLAB? It was quite previous question at 6:33.
How can we import a
No, sir.
large
Export.
resolution image into MATLAB?
No, no, sir. How can we export high resolution image in MATLAB? Export.
How can we export large resolution image into MATLAB? Okay, no problem.
Yes,
So the
like that.
question should be actually how can we import large resolution image into the MATLAB, and the question can also be how can we export large resolution image from MATLAB. So these two questions can be there. So these two are mixed into one. So I will take one by one. So if you have large resolution image, you can import simply by our command, that imread command. It doesn't depend. It doesn't ask that. It is not necessary that resolution should be small for this image. It can be large, as much you have, no problem. But MATLAB memory or a system memory, your system memory should be capable to handle it. So otherwise, it will give you error. If you take a very large resolution, then it will give you error that insufficient memory. Then you can, so that is the limit of resolution, that you cannot go higher than that. So that is the limit of importing a large resolution image. For exporting an image, in large resolution, a better resolution if you want, then this suppose image, this is image you want to save. So resolution, whatever resolution it have, that it will be having if you save it as image. You can save it, file, save it, or export. So from MATLAB it is exported actually. So here you can specify the size. Currently it is auto. Whatever automatically coming, that is there. If you want to specify that no, I want only this much resolution, that I want 720p is 1920, whatever 1920 width in the pixels, in the points, and 720 this resolution I want for YouTube or whatever you want to, wherever you want to save. So then that you can apply this to figure. Then your figure will be converted into that quality, whatever quality of resolution you want, and then you can export this image as JPG or any file, whatever you want, and you can I'm going to save it into desktop, my file or my image, better resolution, whatever my better resolution image. Then that will be exported to that particular place. Okay, so fonts and lines are not here applicable for this. Only size is applicable for this particular figure. Actually, the MATLAB considers image as a figure window. So figure window resolution can be, height and width can be modified from here. If you want to change it into centimeters, then in centimeters also you can change. This is the way we can export from MATLAB in high resolution or better resolution. Otherwise, image resizing is also one option that you can do image resizing in the MATLAB processing in your script, in your M file beforehand. Then automatically in auto also it will give you the better resolution. This is the answer for this query. Any other query?
Kapil Gupta sir, did you get the answer? Okay. Is there any question? Please write in chat box, or you can unmute yourself so that we can go for some query round. We have 7 minutes left in this session, so we don't want to waste our time. We want to use our time, and we request you that if you have any queries related to this session, today's session, you can ask here. Dr. Atul Dwivedi sir is here, so we can
tomorrow. Tomorrow we are planning session for signal processing. Sir, yes.
Sir, okay, sir, that is good, and we will discuss the. We will share the timing in WhatsApp group. That is.
Yeah, timing is also changed for tomorrow, so all of you please check here.
Okay, sir, we will inform that.
Yes, so timing is changed for tomorrow, and tomorrow all of you should be there, because we have an important session by Manit Bhopal faculty. So he will take signal processing with machine learning session. So that is an important session. All of you please join. Any other question? Then we can.
Yes, sir.
Yes, UP Verma sir, please ask.
All X, Y, Z variables are there in the data. So which parameters should be selected, or what will be the better choice of selection for particular axis, say for X or Y, Z, on which a number of data in numeral values have been given. So what will be the recommendation that we will be choosing the Z axis, or we will be choosing the X axis or Y axis, particular parameters?
Okay.
So that better
yes,
resolution.
yeah, question is nice question. I'll say that the data, how to select the data for X and Y
Yeah,
in.
plotting the 2D or 3D.
Yes, suppose we are going to plot a 2D data. First, 2D plotting we do not use in this. In 2D we will see only IMShow command. So
Yes.
it will automatically select Z values to show you the
Yeah.
data. So
Yeah.
when we use this IMShow command, it will automatically select the data. So here we don't have to worry that which data to select. So here data also we don't have to specify. But when you are going to plot, so for plotting, how to select data? That is the question actually. So when we are going to plot, for example, I am plotting, going to plot this in the 3-dimensional 3D bar graph. Okay. Okay. So then here you have to give the data. The command is this. That
Sir, are
bar.
you sir,
I
are you
have not shared the
sharing?
screen. I will share
Sir,
screen.
not visible. Okay, sir.
Sir, just let us go to the MATLAB. In the MATLAB, see, if I am plotting it in the 3D, it's just a bar plot.
Sir, it's not visible now.
It's not visible. I have shared the
No,
screen.
sir.
1 second. Just wait for some time. There's some error. I have shared the screen, but it's not visible.
Yes, sir, not visible.
You can, I think, there may be two names. One name. Usually this happens in this Google Meet that my two names will be coming. Is it visible to others? I'm showing this. Well, then I will stop sharing. Then again share. I have stopped sharing now, and again they're not showing me option also to share.
Sharing is not available. Sharing is not available.
Yes, sharing is not available to me. But I don't know what happened. It is not showing option to share.
Okay, sir. Commands only.
Yes. That is also good option, sir. Sir, there is a suggestion by Dr. B. Sai, sir, that we can share the PDF of all the list of routinely used commands.
Yes, sir. Yeah, yeah.
Yes, yes, that is
So it will
good
be
suggestion, and we will make a list of commands that are commonly used in image processing and signal
Yes.
processing, and we'll share it in the
Okay.
Google Classroom. Yes, that's
Yeah.
a nice suggestion. Okay. If and I don't know why this sharing screen is not working. Otherwise, I could have shown that how to
Okay.
select the data, because this some of the plots they do not ask the XY selection. They ask
Yeah.
only Z
Yeah.
selection. So you have to provide the variable name only that is having the all the values of Z. Okay.
Okay, sir.
So that's what is answer of this.
okay, sir.
Okay, sir. Thank you, sir.
So any queries from your side? We just have last minute. So if you have any queries, please write in chat box. Otherwise, we will end up the session, and we will meet tomorrow with new and interesting creative topic on signal processing.
Okay. Thank you, sir. Bye.
I think
Thank
no
you
queries
all.
in
Thank you
chat
so much.
box.
Thank you, sir.
Yeah. Thank you all for joining and patience
Sir, there
hearing.
is one suggestion
Yeah.
that figure tool will help to. Okay, okay, sir, it is good. Figure tool will have to UP Verma, sir. That is also good for them for him.
Okay,
Yeah.
sir.
Compliment. Thank you.
Thank you, sir. Thank you,
Okay,
sir.
thank you, sir. Suresh, sir, we are getting some problem in your Gmail ID because for last two Google Classrooms we are not able to join you. Actually, what is the problem? We are not able to understand that. Why your email ID is not valid for that?
No, sir. Sir, have you shared your personal Gmail ID?
I mean, sir, the Gmail ID yesterday night someone talked to me, then it was resolved. But some of the
Yes, sir.
videos I am unable to see that because it's asking a permission request because I put a request mail, but I don't know whether your side from your side accepted or not. I don't know. Please go through approval. Okay.
Okay, sir.
Okay, sir.
Sir, if you face any that error, please send the screenshot to me,
Sure, sir. Sure. I do it, sir. Yeah.
because in previous sessions you send this screenshot that class not solved, so we were able to solve that problem. So this now also you can share
Okay.
that why you are not able to access the videos.
Okay, sir. Okay. Thank you.
Because sir, in our side we should be perfect for that. We don't want to make you in trouble.
Sure, sure.
Thank you, sir.
Thank you.
Thanks to all of you. Thanks for participating, interactive participating, because interactive participation makes us more perfect, makes you also more perfect. So
Okay, sir.
thanks once again. For
Thank,
tomorrow's session detail and timing will going to be shared in our Google WhatsApp group tonight.
okay, sir.
Thanks to
Thank you,
all
sir.
of you.
Thank you.
Good
Thank you.
night.
Good day. Good night.